Hi, I'm Eli Hatcher, and I built a computer program that taught itself how to play chess. To do this, I used reinforcement learning. Reinforcement learning is how you teach your dog, basically. You give it a treat if it does what you want, and you maybe tell it no or yell at it if it does what you don't want. And over time, it learns to do the action that gets the treat and not do the action that gets yelled at. So computers, it's basically the same thing, except computers don't care about treats or being yelled at. Instead, what they do is ones and zeros, and you build the program so that it automatically favors the moves that lead to ones and disfavors moves that lead to zeros. The big terms you'll need to know for this video are the agent, that is the computer, the program that is making the decision. Does it go left? Does it go right? Does it move a pawn? Does it move the king? The next term you need to know is the environment. The environment is where the agent is. Is it in a chess game? Is it walking down the street? And the environment also controls what actions are available to the agent. In a chess game, it might be able to move a pawn one forward, but it won't be able to walk around because that's not the environment. The third term you need to know is the state. The state is what specific configuration the environment's in. So in a chess game, it would be where are the pieces on the board? What moves are legal? And if you're walking down the street, the state might be there's a tree to your left and a car on your right, or there's a tree on your right and an open road. And the state then affects what decisions are best. For example, in a chess game, one move in a certain state is great, but that same move in another state might be catastrophic. So the state's really important for the agent to learn context-based moves, not just automatically do this. The final term you need to know is the reward. The reward is the 1 or 0 that the agent gets after an action. This tells the agent whether its move was good or not. Let's jump into how I actually built this thing. First, I have to give a huge shout out to Machine Learning with Phil. I used his great video linked in the description to help structure my code and make sure I had everything I needed. Phil was great. Video super helpful, I highly recommend. The first thing I did with my code was to build the replay buffer class. So this is a class that handles the memory, and it also handles what's called the buffer. So the buffer is basically, it holds the last however many moves in immediate memory. That way it can learn from all of those at once. Next thing I did was actually build my network. So for this I used a specific network class, and I just added in my layers using PyTorch. Finally, I built the agent class. The agent class is the most complicated and calls on both the network and the replay buffer class. The two biggest things the agent class does is choose an action and learn. Choosing an action is relatively easy. There's a balance in reinforcement learning between exploring, trying new moves to see if one is better than what you had before, and exploiting, or taking the best move you know so that you get the reward. So choosing an action is a probabilistic thing. 90% of the time I exploit, or in 10% of the time I explore. I change this percentage. The agent would explore more at first when it has very little idea what's best, and exploit more towards the end when it has more knowledge and is able to better choose. And then, of course, the agent has to learn. So the learning is backpropagation, just like any other neural network. It takes the loss, which in this case is the difference between the reward predicted before the agent took the move and the reward that actually resulted after the move. And it backpropagates it through the neural network to change its weight. So how did my program actually do? I had it play 1 million games, which took about 3 days. Then I had it play my dad, who's rated about 1100 USCF, for any chess players out there that know what that means. My dad easily beat it. So my evaluation as a chess player would be that it is about an average casual player. If you like this video, subscribe to stay up to date on my latest content. You can also check me out on Medium, where I have Reinforcement Learning A to Q, the article that discusses double dueling deep Q networks. You can also check me out on LinkedIn. Thanks.